Hello friends. Today we're exploring two amazing forces, electricity and magnetism. Electricity powers our homes, lights our bulbs, and runs our gadgets. Magnetism is the invisible force behind fridge magnets and compasses. For centuries, people thought electricity and magnetism were unrelated, but science revealed a hidden connection. They're actually two sides of the same coin. Flowing electricity can create magnetism. Yes, electricity can make a magnet. This is called the magnetic effect of electric current. It's a scientific magic trick that changed our world. Today, we'll see how this effect works and why it matters. Are you ready to discover the wonders of electricity and magnetism? Let's begin our journey into this fascinating world. We'll learn how these forces shape our daily lives. Get ready for some simple, amazing science. Electricity and magnetism. Two friends, one incredible story. Let's dive in and see the magic for ourselves. The adventure starts now. To understand the magic, let's first talk about electric current. Everything is made of atoms, and inside atoms are electrons. Electrons carry electric charge and can move through materials. When electrons flow together in one direction, that's electric current. Imagine it like water flowing in a pipe, but with electrons in a wire. Some materials, like copper, let electrons flow easily. These are conductors. Others, like plastic or rubber, block the flow. These are insulators. That's why wires are copper, but coated in plastic for safety. We measure electric current in amperes or amps. The more electrons moving, the higher the current. This flow of electrons brings energy to power lights, fans, and more. Electric current is the foundation of all electrical devices. It's simple. Electrons on the move make things work. Understanding current is the first step to unlocking the secrets of electromagnetism. Now, let's see what happens when current and magnetism meet. The real magic is about to begin. Now, for the exciting part. What happens when current flows through a wire? An invisible magnetic field forms around the wire. This field acts like a magical aura, affecting nearby magnetic materials. The stronger the current, the stronger the magnetic field. The field forms circles around the wire, with the wire at the center. Want to see it? Place a compass near a current-carrying wire. The needle moves. This proves the magnetic field is real and powerful. The discovery that current creates magnetism changed science forever. It revealed a deep connection between two natural forces. This principle, called electromagnetism, powers much of our technology. From gadgets to machines, this effect is everywhere. The simple flow of current has transformed our world. Electromagnetism is a cornerstone of modern physics. Let's see how a simple experiment made this discovery famous. Get ready for a story of scientific surprise. In 1820, Danish scientist Hans Christian Ørsted made a surprising discovery. During a lecture, he noticed a compass needle move when current flowed through a nearby wire. The compass wasn't part of his experiment, it was just there by chance. When Ørsted switched on the current, the needle deflected from north. He realized electricity could affect a magnet. Ørsted repeated the experiment and found the effect was real and repeatable. Reversing the current made the needle move the other way. This was the first clear proof that electricity and magnetism are linked. Ørsted's simple observation sparked a revolution in science. Scientists everywhere began exploring electromagnetism. This discovery laid the foundation for countless inventions. It showed that electricity and magnetism are two aspects of one force. Ørsted's experiment changed how we see the world. Sometimes big breakthroughs come from small, unexpected moments. Let's see how this discovery led to powerful new technology. A straight wire with current creates a magnetic field, but it's not very strong. To boost the effect, scientists coil the wire into loops. A coil acts like a powerful magnet. This is called an electromagnet, a magnet made by electricity. Electromagnets are only magnetic when current flows. Turn off the current, and the magnetism disappears. Want it even stronger? Add a soft iron core inside the coil. The iron core concentrates the magnetic field, making the electromagnet much more powerful. Electromagnets can be switched on and off, making them incredibly useful. They're used in scrapyards to lift heavy metal, in electric bells, and even in computers. Hospitals use giant electromagnets in MRI machines for medical scans. Electromagnets are everywhere, working silently behind the scenes. They're essential in modern technology and industry. From lifting cars to storing data, their uses are endless. The ability to control magnetism with electricity is a game changer. Electromagnets show how science turns simple ideas into powerful tools. Next, let's see how this magic rings your doorbell. The story of the electric bell is up next. Ever wondered how an electric bell rings when you press the button? Inside, there's a clever use of electromagnetism at work. Pressing the switch completes a circuit, sending current through a coil. The coil becomes an electromagnet and pulls a metal armature. Attached to the armature is a hammer that strikes the bell. Ding! But here's the trick. As the armature moves, it breaks the circuit. The electromagnet turns off and a spring pulls the armature back. The circuit closes again, the magnet pulls, and the hammer strikes once more. This rapid make and break repeats, creating a continuous ringing sound. The whole process happens automatically as long as you hold the button. It's a smart, simple use of the magnetic effect of electric current. Electric bells are just one example of electromagnets in action. This principle powers many devices in our daily lives. Next, let's see how electromagnetism makes things move. Literally. Electric motors are up next. Get ready to see science in motion. The magic of electromagnetism keeps ringing in our world. Let's keep exploring. Electric motors are everywhere. From fans to washing machines, they turn electrical energy into motion using electromagnetism. The key, a current-carrying coil inside a magnetic field, feels a force. This force makes the coil spin, creating mechanical energy. The spinning coil is called the rotor. The stationary part is the stator. The stator provides the magnetic field, using magnets or electromagnets. The interaction between the rotor and stator makes the motor turn. To keep the coil spinning, the direction of current must reverse every half turn. This is done by a commutator and brushes, clever components that switch the current. Without this, the motor would just stop after half a turn. This simple principle powers countless machines in our lives. Electric motors are the workhorses of modern technology. They make our world move quietly and efficiently, all thanks to the magnetic effect of electric current. Next, let's see how this effect shapes our entire world. The impact of electromagnetism goes far beyond motors and bells. The magnetic effect of electric current has transformed our world. It's used in power plants to generate electricity by moving magnets and coils. This process, called electromagnetic induction, is the backbone of modern energy. Electromagnets are in loudspeakers, headphones, and computer hard drives. They store and read information as magnetic patterns. Even credit cards use magnetic strips to store data. In medicine, MRI machines use powerful electromagnets for detailed body scans. Maglev trains float above tracks using magnetic levitation. No friction, super speed. In factories, electromagnets sort and move heavy metal objects. The applications are endless, from transportation to healthcare. Electromagnetism is at the heart of our information age. It powers communication, industry, and innovation. Our daily lives depend on this invisible force. The magnetic effect of electric current is truly everywhere. It's a force that shapes the modern world. Let's reflect on the magic of science that makes all this possible. The journey of discovery continues. Today, we've uncovered the deep connection between electricity and magnetism. We saw how a simple current can create a magnetic field. Ørsted's experiment revealed this link and sparked a scientific revolution. Electromagnetism is one of nature's fundamental forces. It powers inventions from electric bells to motors and MRI machines. This knowledge has made our lives easier, safer, and more exciting. Science is about curiosity, observation, and asking questions. Sometimes big discoveries come from small, unexpected moments. Learning science helps us understand and improve our world. The magnetic effect of electric current is real magic, science magic. It's working silently all around us every day. Keep your curiosity alive and keep exploring. The world of science is full of wonders waiting to be discovered. Thank you for joining this adventure into electricity and magnetism. Stay curious, keep learning, and let science inspire you. Until next time, keep exploring the magic of the world around you.